So now next we will look into RLC circuit. Okay. So today we will look into RLC. Last class we have seen RC circuit. Okay. So this is basically an RLC circuit. You have a resistor, inductor and a capacitor. You have a resistor RL inductor and a capacitor in series. You have a resistor, inductor and a capacitor in series and a voltage V is applied across it. Okay. So here you have a switch. Okay. So here we need to analyze the current transient of this RLC circuit. Okay. So now we need to apply KVL rule. Okay, KVL Kirchhoff voltage law to this particular loop, and then we will find the current transient. Okay, so applying KVL we will get inductor L into di by dt across the inductor. What is the voltage? L into di by dt plus then the voltage across the resistor plus the voltage across the capacitor. Okay, the voltage across the inductor will be L into di by dt plus R into I. R into I is the voltage across the resistor plus 1 by C integral I dt. 1 by C integral I dt is the voltage across the capacitor. That will be equal to the total voltage we applied. Okay, then differentiate with respect to t. So you will be getting L into d square I by dt square plus R into di by dt plus integral and differential will cancel. For the third term, integral, here you are having an integral and now you are differentiating. So that will be cancelled. So the remaining will be 1 by c into I is equal to, since we are considering first for a DC voltage, for a DC voltage V will be equal to some 5 volt or 20 volt. So V will be a constant. So differentiating the constant will yield a 0. Now divide throughout by L. So what will be getting? D square I by dt square plus R by L into di by dt plus 1 by LC into I equal to 0 by dividing throughout by L. So this is the differential equation that you want to solve for current value, I value. That means current through the RLC circuit. You need to find out the solution for this particular differential equation. Okay, now we will go to MATLAB and find out the solution for that. So here I am taking sims of I of t, sims of I of t, because I am considering the current transient. Okay, now voltage, I have applied a voltage of 20 volt and resistance 9 ohm, L1 1 Henry. Okay, now capacitance is equal to 0.05 farad. So RLC I have defined as RL and C I have defined. Now I am finding the equation. Okay, so what is my differential equation? I've already told you the differential equation is d square I by dt square, the second order, d square I by dt square plus R by L into di by dt plus 1 by LC into I equal to 0. So same differential of I comma t comma 2. What is this 2 indicate? It is d square I by dt square. This 2 indicates d square I by dt square plus R by L, R1 by L1. Okay, R by L into di by dt plus 1 by LC, 1 by LC into I. You need to put this bracket also for 1 by LC. So 1 by LC into I equal to 0. That is your equation. Okay, so this equation I am putting it as equation 1. Okay, now condition. So you need to put the condition 1. So what is the condition? Here I need to put two conditions. Then only I can solve, because there will be two constants associated with this. For by solving, if you are solving this manually using your particular integral and complementary function, if you are solving this manually, you will get two constants. So in order to find out the particular solution for this, you need to solve for the constant. So in order to solve for two constant, you need two conditions, two initial conditions are there. Okay, and this will be given in the question. The initial conditions will be given in the question. First of all, I of 0 will be equal to 0. That means current at t equal to 0 equal to 0. Then differential of I. Di means differential of I. Okay, di means differential of I at t equal to 0 is equal to 20. So this will be given in the question. Okay, di means differential of I at point at t is equal to 0 will be equal to 20. So how can you find out di? Di I have already found out initially itself. Di, what is di? Di is equal to differential of I, diff of I. In the earlier stage itself I have found out. Okay, di is equal to differential of I hope this is clear. Okay, now condition also I have specified. Now I can solve for using desolve equation 1 comma condition 1. Okay, now t is equal to, you specify a range t 0.005 is to 5, from 0 to 5. Okay, now subs, using subs you can convert it into a numerical variable. Okay, now plot s1, t comma s1. T is the x-axis and s1 is the y-axis. Time is x-axis and s1 is the y-axis. Then in red color it is r. Okay, if you want to plot it in red color it is r, then change the line width. Okay, now title current transient through RLC. Current transient through RLC circuit. Then X label is time and Y label is current through RLC circuit. Current through the RLC circuit. So we will run this, then we will find the output. Okay, so you can find the output like this. The current is initially increasing and then it is decreasing. Here you can see the output. Okay, this output will vary according to the value of R, L and C. This will be dealt in your network theory subject. In your network theory subject, you need to analyze this whole RLC circuit in detail. Okay, so in network theory subject, you will study this RLC circuit. Okay, and there are there can be three response according to R, L value and C value. There can be three response for this current transient. One is under damped, one is critically damped, and one is over damped current. Okay, now we are not going into the details, you will study in the network theory subject. Okay, now if I am changing my V value, here I am applying voltage is equal to 20. Okay, so here please understand that this diff of I you need to take for the second condition. For the second initial condition, di of 0 equal to 20. That is, you are placing another condition for solving the two values, for the two constant value that you will be getting while solving the differential equation. Now you can find out. Okay, suppose voltage V I am applying some other voltage, not a DC voltage like 5, 12, etc. Okay, so in general I can write by applying KVL rule, L into the same equation. Okay, L into di by dt plus R into I plus 1 by C integral I dt equal to the total voltage V. Now L into d square I by dt square, differentiate with respect to t. Okay, plus R into di by dt plus 1 by C I equal to dV by dt. So our voltage V is not a constant DC source. So that is equal to dV by dt. Then divide by L. So when you divide by L, you will get this particular differential equation. On the right hand side, you can see 1 by L into dV by dt, not 0. On the right hand side, 1 by L into dV by dt when you divide it by L. So this equation we can go for the next program for solving this. Okay, so same thing R and RLC. So initially I have Sims. Initially I have initialized this I current I of t as using Sims. Then V is equal to 20 into e raised to minus t. That is my applied voltage. So applied voltage is 20 into e raised to minus t. Okay, now my RLC value I have defined. R equal to 9, L equal to 1, C equal to 0.05 farad. Then differential of I have found out as di. Then equation I have implemented. So only in the right side part it will be differing. So otherwise same. D square I by dt square plus R by L into di by dt plus 1 by LC into I is equal to 1 by L into dV by dt. So this is the difference, 1 by L into dV by dt. Okay, so that is my equation. Now the conditions are also same. First condition I of 0 equal to 0, second condition di of 0 equal to 20. Then using D solve, you can find out equation comma condition. You can find out the solution, and then using subs you convert this solution into a numerical variable, and then you plot this. Okay, you plot this title, then X label and Y label. I hope this is clear. I hope this is clear. This will be the output response. So this is the end of experiment number 5. I hope this is clear. Thank you.